So if you've been watching my video series on building your own laser, then you know I've toiled to design a laser and put it all together. And as of the last video, it's now aligned and we're ready to go. So in this video, we're going to take all of the final fine-tuning steps. And by the end of this, the laser should be ready to use. So let's get going. How's it going, everybody? Steve here, and welcome back to my workshop. And as I mentioned, the laser is now built and properly aligned. And what I want to do is start doing some calibration. And the first thing is actually mechanical. I need to set the limit switches so that 0, is where I want it to be. Then what I'll do is get the laser talking to my computer. After that, I'll show you how to do a bunch of calibration, and we'll start with focus and then we'll move into some more intricate things. By the end of this, the laser will be basically ready for production. So with that, I'll get started with the limit switches. So before I've even turned the laser on, what I'm going to do is set the 0 position for these limit switches. And the first one is the X. And what I'm going to do is just move it over just until it clicks and you can hear it. And then I'll look down and see to make sure that the laser is right over at the edge of the grate. And if it isn't, I can loosen the screws on here and move this forward. It's actually the screws inside here, and move this either forward or back to get the laser set. Now that that one's done, then what I'll do is go over to the Y position, and you can see the same kind of switch here. And what I'll do is I'll pull the laser back again just until it clicks, and then I'll look down and make sure that the tube is just right at the edge of the metal on the front. So that's the calibration. And again, if this one has to move, you can just loosen the screw here and slide it forward or back to get it into the right place. So before we can really do anything with the laser, we need to get it talking to my computer. And the way I'm going to do that is I'm going to use a program called Lightburn. And you can see as soon as I bring it up here, it knows there's no devices connected, so it's asking me to find one. And if I'm using USB, I can click this Find My Laser button and it will just go detect it on my USB bus. But I'm using Ethernet because my laser's on the other side of my shop from my computer, so what I'm going to do is create one manually. And I know I'm using a Rowita controller and it's on Ethernet. Now, if you were using USB, you could click that one, but I'll use Ethernet, and my IP address for my laser, which I've set over on the laser, is this. Oops, sorry, 2. And we'll give it a name, and I'll give it my unofficial model name for my computer, my laser, the 3624. The width of my workspace, the usable width is 865 millimeters and the usable height is 560 millimeters. And I use typically the front left for my origin. You can use anything you want, it doesn't matter. You can use any of the 4 corners. The front left is just easier for me. And once I do that, I can finish, and I click OK, and it's automatically selected that device for me. And if I just do something simple here, like just draw a rectangle and hit frame. Sorry, I also have to have it set for output. And I just hit frame. I can hear my laser actually running over in the other side of my workshop. So it's connected. It now just basically drew the outline of that rectangle on my workspace. So I know it's connected. Okay, the last thing I want to do before we jump into some proper calibration is I want to go to the device settings and verify a couple of things. So certainly my working size was set, as well as my origin when I created the connection. But these are very important settings over here for the Z-axis. Because I have a Z-axis control, I can move the workspace up and down relative to the nozzle. I want to make sure that the Z-axis is enabled. We're going to use that for some of our tests, and I can't stress this enough. Always make sure that this is set to relative moves, because in some of the tests, we'll defocus the laser a bit, and we'll say move the laser focus by 1 millimeter, or -1, which is even worse. We want to make sure that it's not moving to what it thinks is the -1 Z offset. We want to move by -1. So make sure those two are set. You could optimize Z-axis moves, but we don't actually use the Z-axis all that much. It's more just to set focus. So anyway, make sure that both of those are set, and now we can kind of proceed to the next step here. So now that my computer's talking to my laser, I can do a couple of really basic mechanical calibrations. And the first one is really around movement. We want to make sure that when Lightburn, in this case Lightburn, asks for 100 millimeters of movement in any particular direction, the laser actually moves 100 millimeters, not 105 or 75 or some other random number. And initially it will be pretty random, but the way we're going to solve that is, right now the laser thinks it's at 0, 0. So what we're going to do is put a mark there, and then we'll move, say, 100 millimeters, and we'll say go, and I can hear my laser moving, and now it thinks it's 100 millimeters. It's moved 100 millimeters, and really all we're going to do is go measure that distance. And again, this one is rough. We'll refine this later, but this is really just to make sure the laser doesn't kind of go out of range. So the first thing I'll do is I'll mark this 0, 0 position, then I'll move, say, 200 millimeters, and I'll measure it and see what it is, and I'll come back with a calibration. So let me go do that, and I'll come back. Okay, so the laser now thinks it's at 0, 0, and that's because we set our limit switches earlier. And what I'm going to do, I put a piece of blue tape down, and I'm just going to put a black dot there. And now what I'll do is I'll move the laser over 200 millimeters. So I'm back in Lightburn. I'm going to go. So it moved the laser, and I'm going to do the same thing. I'll put just a piece of tape down and just put a dot there. And again, we're only doing this roughly. Later on, we can calibrate. We can do some additional calibration. Now, since I'm here, I'll also do the y-axis, and I'll just move it 100 millimeters. And you can see, unfortunately, it's blocking the camera, but that's okay. All I'm doing is exactly the same thing. So I put a dot there, and now what I'll do is I'll just get the laser out of the way. And I'll show you what we're going to do here. So now we need a measuring tape, and my measuring tape will also measure in millimeters. So I asked for 200 millimeters, and it looks like I got about 198 millimeters on the x-axis, and I asked for 50 millimeters on the y, and I got I asked for 100 millimeters on the Y, and I got about 90, and sorry, my fat hand is in the way here, but I got about 98, we'll say. So that'll be good enough for us to test. Okay, so the last thing I'll do is the Z-axis. So I move the nozzle back over to the 0, 0 position, and I can read the display on the Rowita controller, and it says X and Y are both 0. So now what I want to do is move the laser till it's almost touching. We don't have to be deadly accurate here. Again, we're just trying to get close. And on the Rowita display, it will tell me what it thinks the Z-axis height is, which right now says 2,971 millimeters. Now what I'm going to do is move the laser, the Z-axis, say 200 millimeters, or what it thinks is 200 millimeters. And on the display, that would be 3171. So let me move the axis down to 3171. Or something reasonably close. And I'm just using the controls on the display, the Ruida display controller. So 3171. Getting close. There we go. 3171. And then I can just measure what I have here. And again, this is just a very rough measurement, and you can see it actually isn't too bad. It moved about 200 millimeters, so we'll call that close enough. And there we go. So now that we know our numbers, we can go enter those into Lightburn. Okay, so I'm back in Lightburn, and as I mentioned, I'm going to bring up this machine settings view, and I'll click this calibrate axes button down at the bottom here, and we'll start with X. So we asked for a 200 millimeter movement, and what we actually got was around 198 millimeters. And so that one is the X, and for the Y we asked for 100 millimeters, and we got around 98. And the Z-axis I think is fine. We asked for 200 and we got 200. So let's just leave those. And then you want to click this right button. So what that'll do is at least ensure that roughly the X and Y in particular are calibrated, and that will allow us to do the rest of our testing here. So to get started here, we haven't set the focus, and you can see, actually if I move the laser over, you can see I've got the focus pin kind of pulled out here. It's just sitting here, and that's because we haven't really calibrated it yet. So the only way to do this initially is use my handy dandy focus gauge here, and this will get us roughly in, and what I'm going to try and do is get it around 8 millimeters. The lens is actually sitting in here, and it's a 2-inch lens, so it's roughly 2 inches from where the lens is down to the surface, and that's what we're trying to get to. And in order to make that happen, that would be roughly an 8 millimeter, which is the second step on here. So let me move the laser up. And that's roughly 8 millimeters, and that's good enough to get us started, because the first thing we're going to do is a focus test, and that will determine how the laser should be set. Okay, so back in Lightburn, I'm going to load, I created a focus test image, and if I zoom in on it here, you've probably seen lots of these floating around on laser sites and just general internet. What most of them do, however, is they require an absolute measurement on the side. What I did instead was say, I'm trying to get the thinnest line to be the 0 line, and I can run this test, and whichever line is the thinnest line on this drawing will tell me how far I need to move down. So let's say -3 was the thinnest line. What that really means is I need to move the focus down 3 millimeters to get to 0, and similarly the other direction, I need to move up 3 millimeters. And the way this works is there's actually quite a complicated list of lines here, and you can see the red line, which is the one selected there, independent of the speed. What it's doing is moving the offset closer by 400 by 4 millimeters. So and each one of these lines will actually move the Z-axis. This is one of the powerful features of Lightburn, by the way, where you can just say for this any line of this particular color I want it to be defocused, is what we're really doing here, by 4 millimeters. So and each of these lines you'll see changes that focus, and that's how we'll determine where the best focus is. So let me run this on the laser, and I'll come back and I'll show you what it looks like. Okay, so let's take a look at the results, and you can see certainly down at the bottom and at the top the line is a little thicker, and maybe you need a magnifying glass to see this, but really it looks like the thinnest lines are we're pretty close already, in around here, and I'm going to say that the minus 0.5 line is probably the thinnest. So what I'm going to do is move the focus down from, we're about 8 millimeters now. So what I really want is about 8.5 millimeters. And so let me show you how to adjust that. Okay, so first thing we need to do now is set the focus pin. And the way we're going to do that is loosen off the screw here, just so that we can slide it down. And so when it's loose, now the next thing I'm going to do is lower the tube down to the piece of material, just to the point where it touches. And so this is a pretty precise movement. You have to be very careful. And you can see I can actually press the material down here because it's got a bit of a warp in it. But so that gets me pretty close. So we'll call that 0. And now what I need to do is push the focus pin down till it just closes. And the way to see this is on the Rowita controller, you'll see a light come on when this, the Z limit light, when this pen is down. Which is right about there. And actually I'll back it off just a bit. Okay. So now that gets us to the point where we can now set the focus, and we know we want 8.5 millimeters. I've gone back into the machine settings, and you can do all of this from the Rowita controller as well, but I just find it easier here. So the first thing I want to do is enable focus. So we'll set that to true. And then I want to set the focus distance, which in our case will be 8.5 millimeters. And really that's all we need to do. And we can do a right here. So if you now went over to the laser, to the Rowita control panel and hit the focus button with an enter, it would go and focus the laser, and it would back off. You'd see it come down to the pen, to the Z limit, which is our 0, and then it would back off 8.5 millimeters, and that's the place where we'll want to cut. And again, you can watch other videos from other laser guys, laser people, and you'll see different ways of doing this focus. I just find this is the easiest way. Some people do, complicated things with varying thicknesses of material, and it's just, it's just complex. It's overly complex. So this is the simplest way I know how to do it. So now that we know the laser's in focus, the next thing we need to deal with is something called scanning offset. And this is really just cumulative error in the system from one end to the other. And you actually saw this most likely in the focus test, and I'll put an image up above here. These are the numbers that were engraved on the focus test. And notice that they all look kind of ghosted. So to really understand this, let's have a little bit of a theory lesson, and then we'll figure out how to correct it. So what scanning offset is effectively adding up all of the error between direction changes in the laser. So if we were drawing a rectangle up here, the laser basically draws in lines. It draws left to right and then right to left, and all the way up until it gets a rectangle formed. And the way it does that is the laser head moves over to where it's supposed to start, and it will start drawing a line. And when it's done, it stops the laser, and it will just kind of keep going for a while, right? There's inertia, there's just a lot of things that add up. So by the time it's finished this line, the laser head may be actually over here. So when it starts the next line, the laser moves up and it's coming back, but it may not actually start at this same point. And the reason for that is this latency in mechanics, so the belts might stretch and so on. But there's also electrical latency. So by the time the controller says fire the laser, the power supply doesn't instantly turn on, and the laser tube itself doesn't instantly turn on. So there's some time that it takes to make that happen. So by the time the laser turns around, it's supposed to fire here, but by the time it actually fires, it may be a couple milliseconds later, but the head is moving. So by the time it comes down, it may actually not fire to here. And then it starts to fire, and it will draw, and then the controller will say stop drawing, but it takes a little while for all of that to stop. So what you end up with is this imprecision in the lines. And the way to correct scanning offset, and we can do it in software, is we'll draw a rectangle and measure these lines. And the way we measure it, the offset is actually this value. So we'll draw a scanned rectangle, and then we'll measure this, and we can enter it into the Lightburn software, and we can fix this problem. So that's what we're going to do first, and we need to do this so that we can see all of our other tests, because other tests have numbers and things that get engraved onto the sample, and if they're all messed up, we won't be able to read them. So now that you know what scanning offset is, how do we fix it? Well, obviously we're gonna do some laser work. So I created this simple example for an offset test, and you can see the numbers down the side here. These are the speed of the laser's moving in millimeters per second. So it stands to reason that the faster you go, the more error you're going to have, because the laser's just moving faster. So we're going to try it at different speeds, and we're going to draw a rectangle. And if we look at the settings for these, you'll notice that for the red rectangle, the speed, of course, is 30, because that's what we're supposed to be drawing. We have really low power so that we don't carve through the piece of material with our 90-watt laser. But what's important here is this line interval value, and it's currently set to 0.5. And what that really means is that as we're scanning to fill in this rectangle, the lines that we scan will be 0.5 millimeter apart. And the reason for that is so that we can actually see the individual lines and measure the difference between the ends of each line. And so all of these values for each of these speeds is fundamentally the same, with the only variation being the speed that the laser is moving. And we can take a look at, if we do a preview here and we zoom in, you can see these lines, and you can see this is how they're supposed to look. Start and end every line in the same place from an X position. So what we'll actually get is something quite different. So let me go fire this off to the laser and cut it out, and I'll show you what the result is. Okay, so if we start taking a look at the results here, you can see even at 30 there's a bit of a jaggy edge. It certainly gets progressively worse as we go, so by the time we're down to 700, it's pretty significant. So what we're going to do is, as I mentioned, the way we'll do it is we'll measure these, and we can just take any one of them, and we're just measuring between, I'll do it this way. We're just measuring between where the first line ends and the next line begins. So we get a difference, and you can see it's like, if we tighten this up to something close, it's about 2.45 for 300 millimeters. Now, what I've noticed is the actual offset that I enter into into Lightburn is about half of what I measure. That kind of contradicts what Lightburn says in their documentation, but your mileage may vary, but I just find if I measure and I divide it by 2, I come pretty close the first time. Now, the other thing I'm going to point out here, and we'll look at this too at some point, you can see the ends of some of these lines are actually a little kind of ripply. They're not straight on both ends, and that's actually due to the acceleration being too high, so we may lower that as well, just to make sure that the lines don't have this little hook in the end. And anyway, let's go over to Lightburn and we'll start playing with this. Okay, so now that I know what the offsets are and I've measured them all, I can go back up to device settings, and in this first screen you'll see this option called scanning offset adjust and this enable offset, scanning offset. So I'm going to turn that on, and then what I'm going to do is add values for each of the speeds that I have. And the first one was 30, and the number I've calculated there would be 0.17. And I'll continue to do this for all of the remaining values. Okay, so with all of the scanning offset values set for the first cut, I'm going to do one more thing. I mentioned the acceleration, and in this case it's the acceleration on the x-axis, and we could also do these for the y-axis, but for now I'll just do this. And notice it for engraving, which is what we're doing when we're drawing these rectangles, it's set to 3000. I'm going to drop that down to 2500 and see what the impact is. The other thing I noticed, incidentally, was my maximum speed on the x-axis was set to 500 millimeters per second, so the 600 and 700 millimeter tests were basically invalid. So I'm going to change that to 700 as well, and that will actually impact the numbers that I've set over here. Notice that 5, 6, and 7, not coincidentally, were all the same. So those values will have to change as well. But for now, let's just cut this out again. We'll do another scanning offset test, and we'll see what the results are. So after a bit of trial and tribulation, I finally got this cut here, this piece, and this is kind of the final scanning offset settings for me. And you just have to play around with it. There's no exact science here. As you can tell from the piles of wood behind me, I toiled on this for a while to get it right. I spent a bit of time trying to get the wobble fixed as well, on the ends of the lines. That actually happens when the laser is shifting lines, so it's really a y-axis problem. I managed to get it a bit better, but in reality, it's just a design limitation, I think, of my design. I could tighten up the belts. Maybe the belts are a little loose, or check all of the screws to make sure there's nothing loose. But in general, it's a mechanical problem. I did also manage to get my laser running at 700 millimeters per second, which is really the maximum for this laser. There's just a lot of mass moving back and forth there on the gantry. And the way I solve that is to really slow down the acceleration of the x-axis. Make your choice. I'm an old guy, so I can deal with my laser being a little slower because the acceleration is low, but you may want it faster. But understand that if the acceleration goes up, then the factor of the weight becomes a bigger and bigger problem. However, if you lower the acceleration, then overshoot becomes a bigger problem, and you just have to weigh it off for your particular application. So it's a bit tedious, but play around with it. So the last thing I'm going to talk about in this video as far as calibration is scaling on the X and Y axes. And what that really means is if you're cutting a 50 millimeter square out of a piece of material, it actually measures exactly 50 millimeters in both directions, or at least as close to 50 millimeters as we can get. And we'll stop there. There's a million different other parameters you can play with. If you're doing images, you may want to set things up. If you're cutting thicker materials, you may want to set different things up. But for now, we'll stop with this. So let's get going on the scaling, and we'll call it a day. Okay, so I've got my supposed 50 millimeter square here, and I'm just going to lay it down and measure it. And so on the X direction, I have it measuring 50.22, and on the Y direction, it's measuring 50.9. So it's out a bit, and you can check both sides if you want. So 51.18, so it's not quite, well, 51.9, 50.97, and on the X, 50.06. So what I'll do is I'll show you how to set the scale for these. It's pretty simple. And finally, I'm back in Lightburn, and I'll bring up the machine settings, which is under the edit menu. And again, we'll go back to this calibrate axis button, and we're going to do the X axis, and I'll just measure again here just for accuracy. So the X axis I measured 50.02. And so what I'm going to say is I requested 50, and what I actually got was 50.02. And on the y-axis, I got 50.95. So I can select the y-axis now. And again, I requested 50 millimeters, and I got 50.95. And that's it. I'll write it. And if I cut another square out, it'll be 50 by 50. If it isn't, I can continue to iterate through those settings until I get it to 50 by 50 exactly. Anyway, that's scaling it. Like I said, it's pretty simple, and but it's very important to get your scale proper so that things fit the way you expect them to. So, and the one last thing I'm going to do is, now that I've toiled to create all of these settings and get everything accurate, I'm going to save this, and I can just save it as any configuration file, and I'll call it SP3624 config, and that way if I ever have to reset my laser, I can just load those configuration parameters back in, and everything will carry on the way it was before. So there you go, the laser's now calibrated and ready to go for production. And certainly I'd like to say this is an easy process calibration, but in reality, the amount of tedium far outweighs the actual knowledge difficulty, we'll say. But you're going to spend time if you're really neurotic about getting perfect calibration, and I fall into that camp to some degree, then you're going to want to spend time. There's definitely a lot more parameters you can play with, and we can cover those in future videos if you're really that interested. But for now, I'll call this good enough. I don't do a lot of photo engraving, but if you did, you might want to do some calibration around grayscale, for example. But I won't bother here. Anyway, we'll call this complete, and I'll do one more video, just kind of a roundup summary. We haven't really talked about things like the outer skin of the laser, and we'll cover that a bit, and we'll wind this down. I'd really like to get back to some project work for a change. Anyway, we'll call it a video, and as always, go make your world, and I'll see you next time.